Good afternoon, everyone. My name is Ben-Alta. I'm Business Development Manager at AWS, and thank you for coming to our session, The Life of a Click. What to expect from the session? So, how many of you are doing Clickstream Analytics today? Nice. How many are using Hadoop for that? Redshift? Kinesis? Okay. How many are not doing it, but they are looking at it from business perspective, how to do it? Interesting. Okay, so we're going to talk about common patterns for Clickstream Analytics, give you some tips how you utilize EMR, Kinesis for doing this type of workload on AWS. And for your main entry, we'll have Rick McFarland, who is the Vice President of Data Services at Hearst, talk about their journey of Clickstream Analytics at Hearst. So, Clickstream Analytics, it really means business value. Regardless which vertical you're working today, whether it's consumer online, e-commerce, it can be banking, if you heard Capital One today, moving to AWS using their digital platform, Internet of Things. We want to identify what our customers are doing on our digital assets. So when we say Clickstream, it can be a click for advertising that they are using later on to aggregate data and analyze them. We're looking about key performance indicators that we are capturing. And other type of use cases that are more advanced are things like recommendation engine. So I'm on the website, I buy something, you want to do an upsell and suggest the next product or put the right advertising promotion banner to the customer. And what customers are doing, they analyze these collections of weblogs or click streams, but there are some challenges. And the challenges are around the velocity of the data. So some of you are familiar with omnichannel weblogs, going to weblogs, your homegrown weblogs that you generate. It can be in different format. It can be a JSON, it can be a TSV, CSV, Avro. We know many, and there are many types of data that, and the volume is massive, and you need to analyze it. And I always like to give this example. How many wrote MapReduce in their life? Good. So you remember this one. Hello world, first programming in Hadoop, doing word count. You have a nice 1 gigabyte of text files, you write your program, you know how many words I have in my large object. But this is really to understand how MapReduce works, doing the sort, shuffling. But the real project, or the real first project that most of the customers that I worked with, this is what they start. They have a collection of weblogs, and they get really messy weblogs. You have cookies, you have a query, you need to do ipconfig, you need to clean that data. And in the end of the day, many of the customers, what they do, they really not create nice visualization or aggregation. And this is really the basic thing I've seen within the last 6-7 years that customers are doing. And I'm going to share with you how it's evolved during the years. So the first pattern, and this is very common, we use Flume or Kafka, land the data on HDFS. We create Hive tables accessing terabytes of data. We run a query with some visualization tool or with your command line, and you can go make yourself a coffee. The query runs for a long, long time. This is how it started. See people smiling, so you're familiar with that. So the next phase was, okay, it's quite slow, so let's aggregate it. We'll use Pig, we'll run some ETLs, we'll build the aggregate data, and we'll push it back to our data warehouse. We have customers that loading these sets to Redshift. I saw customers that loading it to Vertica. And actually, they get low latency when they retrieve this type of data, and they offload really the ETL to do it in Hadoop. But The next generation is really using HDFS. Now customers look, okay, I have weblogs, but I have some reference tables. I want to use Scoop to push that also to HDFS. And I don't really need to do the ETL. There are some really nice applications. So Cloudera came up with Impala, Spark SQL, Presto. Last week, Strata conference in New York, I think there were over 5 companies that are doing a SQL engine on Hadoop. Each one of them said that they have the best performance, which is funny. But eventually, we are like rewriting databases in a nutshell. So you have TES and different type of improvements to query HDFS for the data logs. So how it looks in AWS, what customers, and this is a very common pattern that we see what customers are doing today. We have the collections of the web logs. Usually you have an agent, sits on a large server. You collect all the data. You can use Kinesis stream and write a KCL and dump the data into S3. Then we run with EMR the cleanings. We'll use it as an ETL grid. We have really nice data sets, and we can send it back to S3 because, like, for example, if you're an advertising company, all you do is the output you send back to another agency, or you have another customers that you need to push feeds. Today, we see a lot of integration between companies that instead of sending FTP, they use bucket policy, and they just give them access to the output bucket when they generate the aggregated data set. Or you can have your data warehouse using your BI and load the aggregated data set to Redshift for analysis. But it's not enough. Why it's not enough? Because, as I said in the beginning, the Clickstream has value, and business wants to know answers now. So traditionally, if you're looking on weblogs, many customers move like once a week to once a day to maybe twice a day. But today you want to analyze it continuously. You want to use the Clickstream to create actions now and provide your business visibility of what the users are doing. If you're advertising, how you do like impressions, seasonization in real time, this type of algorithms that you want to know in a near real time. And we use real time, which is really near real time. We want to get to the minute seconds level of what happens. So from the time the customers click or run any transaction on your digital assets, or when you get the data, you want to be able to analyze it and process it and really understand there is value with that. So whether you're doing a micro batch aggregation or building a time windowing series, this is where we see the industry moving from really batch and real time to near real time. But there is a hybrid approach. You still have massive data that you load once a month, but really in the context of clickstreams and weblogs, we see the trends of really moving into that notion of near real time. So just to recap how you do that. So we'll talk about Amazon Kinesis streams, as you heard today in Andy's keynotes. Amazon Kinesis streams is managed service, the streaming ingestion, and provide you continuous processing on your streams. What's unique with Kinesis that you can have multiple applications that process the data process the clickstream data or any data that is blob, and you can have one application that load it to S3 as your data lake. You can have one application that load it to Redshift. One application you can use EMR to process the data, or DynamoDB, or we have custom application that customers are building uses the Kinesis client libraries. Another major component is the Elastic MapReduce, Amazon EMR. It's a managed service that was introduced back in 2010, provide you Hadoop as a service. We had major change within the product, and we actually re-architect, and we're using the Apache BigTop as the engine, and Apache Spark is a first-class citizen within EMR. Recap on Apache Spark, it's a distributed engine that runs in memory, and it has Spark core. It's written in Scala, and it has Spark SQL and Spark streaming. That provides today to customers to do different things with much better latency when they did with Hive or with the paradigm of MapReduce or Hadoop, and it really changed the economics. So when you use Spark, if you're having a MapReduce heavy I/O intensive, you use the ephemeral storage of your instances. When you use Spark Job, it's running in memory. That means that you're doing much less I/O and you're doing more compute or memory intensive. And this is where the benefits from cost of processing Clickstream come into the picture. How many are using Spot instances with VMR? How many are not using at all? Okay, good. So Spot instances are the way for you to bid for compute hour, and you can use it with VMR. So if you remember with VMR, you have the concept of master, core, and task nodes, where the difference, the core node has ephemeral storage, the HDFS, means if the cluster, if this node is down, you're losing data. With task node, you don't store anything. It's just giving you a horsepower to your processing. So if we do the math, let's say that you have 10 nodes cluster that runs for 14 hours, and it costs you $1 per 1 hour, means that for 14 hours you will pay $140. Now we'll add 10 more nodes that's running on Spot, and we will bid that for 50 cents. That means that your cost for 20 nodes cluster for 7 hours, because you added additional 10 nodes, you will pay $70 for the 20 core nodes, and you will pay $35 for the ones that are running on Spot instances. Total $105, and this is really rough math. We have customers that save over 70% when using Spot instances in processing. So less time, less cost, use Spot, especially if you have Spark jobs, and especially if you are utilizing Hadoop today. And we also found that many customers are using Hadoop just as an ETL grid. They clean the data and they load it to somewhere else. And why do you need a persistent Hadoop cluster to do this type of activity when you can use S3 as your HDFS or use your data lake and have multiple EMR cluster processing the data and really focusing on your insight. So how it looks today, and we talk about batch and new real-time and interactive processing. So you use Kinesis, you use Spark streaming with Amazon Kinesis, and I will give you some tips about how these two together really works nice. And you can have multiple EMR clusters for data scientists. So today, very common, and we see it in many occasions, we have customers that they have a data science team, and they have many analysts. They like to use R and different algorithms, and they want to access all the data because you want to have a data-driven company and the customer to access the data. So the day of a life of a data scientist, he come in the morning, he will create his own cluster using Spot instances. When he's done his job or his work, he can go home, he terminate the cluster, and that's it. You pay for what you use, and you don't need a persistent cluster and start having problem with one cluster, multiple users using the same jobs and get into some race condition, etc. So this is very common. Like you can install a notebook, Jupyter, Python, and right. Additionally, if you have a data warehouse BI needs, you can load the aggregated data set into Redshift and use visualization. You can use the Tableau or whatever your preference, or what we just introduced today and announced today. That's something that you can use as well. The trick with the pixels. So this is quite interesting. So when you use Kinesis, and let's say that you have a web page, and you want to track some of the transactions on the page, right? One of the tricks that we see that many advertising companies, and I see other customers copying the same method, they use the pixel HTTP GET. How many are familiar with this trick? Like, oh, okay, we have many ad tech guys here. So what you do usually, you create a small JavaScript that runs on your page, and you request from a server, give me a pixel. It can be less than 1 byte. And what they do, they concatenate all the information that I want to capture about the user, like which browser is using, up to which transaction, and take all that data and push it into your HTTP server, and you will get a response, but you can capture the clickstream data. How you do it with Kinesis, so customers, what they do, they use Elastic Beanstalk to create an application that it's like a Kinesis proxy, and that will filter, because if you have scenarios that someone crawl or you have bots, so you can filter those, but you can use really to centralize your clickstream ingestion process and run it through Kinesis. That's one trick, because then it's a data record that you push, and it's a blob, and you can convert it to JSON if you like to work with JSON format or any other format. So I told you about some tips. So Amazon Kinesis applications, when you build it, so Databricks, they created an ASL for Kinesis. You can use Maven and just build it. But you can use Spark streaming with Kinesis, with very easy to process the data on your stream using Scala or PySpark to process data on the stream. The concept of shards, if you are not using Amazon Kinesis Firehose that we announced today, we always recommend that you will have a headroom for catching up with data in stream. So right now, you know, data in Kinesis stream is stored up to 24 hours. So let's say that you have to catch up, so you want to have more shards, just in case you won't have a backlog. And of course, when you use KCL, it uses DynamoDB for checkpoint, so give name that is unique to your application, so you won't have any issues like, because it's a one-to-one, it's your application X, so that's the name of the table in Kinesis, and of course, provision the throughput. Now, the table on DynamoDB is created automatically. It's not something that you need to maintain or create it manually. When using Spark on EMR, so as I said, Apache Spark is a first-class citizen with Amazon EMR, and starting version 3.8, you don't need any more Bootstrap to build Spark up, and it's coming native. With the new release of EMR last week, EMR 4.1.0, we have Spark 1.5, which is the latest release. You can use yarn cluster, of course, if you have multiple nodes that you're running it. And other tips like serialization, use Cairo parameter. So that's some tips. Again, this is a 300-level session, so I didn't go and explain like what is S3. I assume that you all know. But I would like now to invite Rick McFarland, who is Vice President at Hearst, that he will talk about their experience with Clickstream Analytics and learn about the life of a click at Hearst. So thank you very much. Yo.
John. Thanks, Roy. Hello. Thanks, Amazon. Thanks for joining me today and giving me the opportunity to share with you some of the stuff that Hearst is doing with AWS. But in the theme that Roy started, let me start by asking, how many of you have ever heard of Hearst before? How about Hearst the company? Lost some hands there. How about Hearst before you saw that this meeting was coming up? Good. Good. So I think what I'll start with is a little background on Hearst, because it does give us a nice context for how we developed our Clickstream. So Hearst is actually a collection of 200 companies in over 100 countries. We are a magazine publisher. You may recognize some of these brands. We have 20 US titles and over 300 international editions. We're a television broadcaster. We have 31 television stations across the country. You may recognize a few of those. We're a newspaper publisher. This is how we started 128 years ago. Some pretty cool brands like the San Francisco Chronicle. And what's also interesting is we're also a business-to-business data provider. We provide businesses with data in the medical space, the automotive space, and the finance space. Let's see if this works. So a lot of people refer to Hearst as a publisher, but I may be a little bit biased because I run the data team. I actually think of Hearst as a data creation company. Our data, our creators of data, our editors, create the data that fuels the apps and the tools that you use every day. Our data creators give you the information you need to plan your day, the weather, the school closings. Our data creators give you the news. They also give you the culture and some fashion advice and everything you ever wanted to know about Kim Kardashian as well. So Hearst is a collection of companies, and each of these companies operate independently and generate terabytes of data every single day. We actually have measured it. We actually collect a petabyte of data a year from all of our different sites. 3 years ago, Hearst established a central organization called the Data Services Team, and we have a very simple mission. Our mission is to ensure that Hearst, as a corporation, leverages all of this combined data that it generates. So our challenge is, or still is actually unifying all of the data streams that all of our individual companies create. We also wanted to develop a platform for analytics and product creation for the rest of the company to use. And we did this using AWS resources. And I'm going to share with you today the pipeline, we call it the data pipeline, that we generated in a very short amount of time. And I'll share with you the experiences that we had along the way. And hopefully, if you're making one yourself, you'll get some tips or tricks and maybe be able to do it quicker than we were. But sometimes it's the journey that's important, right? Before I get into the pipeline and give you all the details on the Amazon architecture, a lot of the pipelines that we design or have designed are motivated by products, the products that actually are at the end of the pipeline that use the data. So I want to show you one of the major motivators of our pipeline, which is a product that is used by our editors. It's called Buzzing at Hearst. Actually, it's on display at our booth, 1156 in Hall C, if you're curious and you want to play with it. So imagine a Yahoo for editors, but it has to be instantaneous and it has to be predictive. And we've been using this tool for the last 6 months, and the results have been very interesting and quite impressive based on the fact that we're incrementing our clicks, our number of page views by 25%, because what the editors use the tool to do is to actually take a piece of content that's actually trending on one of their sites and circulate it and syndicate it across to all the other sites. So we're actually leveraging the power of our 350 sites to circulate articles and get incremental click rates, incremental page views at 25 to almost 30%, which if you're a revenue person, those numbers translate to a nice increase on revenue. I can't tell you how much that is, but so basically, it's a very valuable tool which has some very distinct requirements that were brought back to the data team. And we, as the data team, we broke the requirements from the developers down into our engineering requirements. And these engineering requirements are the ones that actually dictate the structure of our data pipeline. And I've kind of highlighted the main ones. The number one and two goals of this pipeline is it has to have a throughput goal, which is how much, I always think of throughput and latency as how much money you can make and how fast you can get that first dollar. So the throughput goal is how we have to be able to get all 350 websites to funnel their data through this pipeline. That's very important because otherwise you're not leveraging your whole capabilities. We have a latency goal. We need to get it from click to tool in 5 minutes, and actually that requirement's down to 2 minutes now. So that's how fast you can get $1. It's the latency. It needs to be agile. The tool needs to be able to be easily and quickly, the pipeline needs to be able to be quickly changed if we add some variables or change things along the way. As you know, some data pipelines are very brittle. You get what you get, and you like it. But this one has to be agile, so you can easily add new elements at the beginning of the pipeline, and they have to be able to quickly go through all the way to the end. We have some very unique metrics. The data science team is focused not on lagging metrics, on reporting page views or clicks that happened yesterday or an hour ago. We want to build some really cool, funky functions or models that actually are predictive and actually say, I think this article will be trending in an hour from now or in 2 hours. Predict the future. Leading metrics. We have data reporting windows. The editors want to see what happened in the last hour, the last day, and the last week, and the last month. So it's not a real-time tool like a lot of you may be thinking of. It actually has to be able to look at a whole bunch of really big windows of time. We have to be able to, our front-end developers are building this thing from scratch. You can't just buy the the Yahoo website model out of the box. So the end of the pipeline, which is an API, has to be very flexible about what that API endpoints can be or look like so that they can feed the requirements of the front-end guys. Because they want their front ends to work as fast as possible, and so their requirements on the API are just give me the data exactly this way. Now here's the big problem, the hardest problem, is we have all these 350 websites operating individually. The whole process, the whole data pipeline has to be implemented without affecting any of those guys' day-to-day operations. So that's actually kind of hard to do if you can't shut down a website or tell them to add things. So let's look at the assets I had to work with 3 years ago when we first started off this project. We actually had a very static clickstream collection process in place. What I mean by static is that we had the ability to collect data on some of our websites via Clickstream, but it happened at a daily basis, as a daily batch. And it would update and get put into a Netezza data warehouse, which we could query very nicely. Netezza is great for that. The problem is that we could do only ad hoc queries, and it wasn't productionalizable. And we were only cranking about 30 gigabytes of data a day through there. One other very important asset that we had, which is will be one of my first tips, we were able to implement on all of our websites a tag management system. For those of you not familiar with the tag management system, that's basically a container or a bucket or JavaScript that goes on the web page, and it's a container where you put all of your tags. That's what it's traditionally known as. But what a tag management system really is, to me, is it's a code distribution mechanism. By putting this tag manager on every one of our pages, it centralizes the ability to distribute tags or JavaScript to all of the web pages instantaneously. So I'll get back to that here in a second. So before I show you the full data pipeline, I'm going to take it apart because it didn't get created in one day. It actually rolled out over time. The first part of the data pipeline, if you're going to build one, is you got to start with ingest. You have to be able to collect your data. And the way I'm going to do this, the rest of the presentation is I'm going to show you a section of the pipeline, and then I'm going to give you a bit of code for those of you that want to take something away. I always want to have a little bit of cool code snippets whenever I go to one of these. We'll have a little bit of code snippets with some tips. So the beginning of our pipeline was the ingest, and as I mentioned earlier, well, first of all, we have to implement the JavaScript on all the sites. So Roy alluded to this earlier, the HTTP request. We have to implement JavaScript on all the sites to be able to start transmitting data into our Clickstream. And we have to do this without interrupting their day-to-day. So because we had a tag manager on all of our websites, and that tag manager has the ability to centrally, I can give code to one single person centrally, and that person can distribute the code without asking permission necessarily. We usually ask permission, but you can actually put the code on the page without the websites knowing it. So the first tip is definitely, if you have a very big network of sites, to implement a tag management solution. The vendor we used is Insighten, a good partner. We then implemented an elastic beanstalk with Node.js, which exposes the HTTP endpoint, which Roy alluded to earlier in his presentation. So we're transmitting the data off of the page that we're interested in and sticking it on an HTTP request and transmitting it over via Node.js. And that Node.js is putting it onto a Kinesis stream. And this was in the days before the announcement of Firehose. So we had a KCL library also, which pushed the data into an S3 bucket. So I'm basically trying to create a data lake in S3 of all of our Clickstream data. My first job is to get every action on every one of our websites stuck into S3. Here's a Node.js snippet. I know it's hard to read, but this presentation will be available later on the internet. And basically, some key tips here. I'm going to have to speed up, I think. It's important to get a good partition key so that you evenly distribute all of your data across all the shards in your Kinesis stream. You want to make sure you do asynchronous site calls so you don't interrupt the loads on the page. So you have to make sure you have that asynchronous series call. We also use the Node.js to put a server timestamp into the stream because the web timestamps, the stuff that comes off the web server, is unreliable. And finally, one of the most important things to do, and this is an option, but I highly recommend it, is to use JSON formatting when you push your stuff on the stream. This will allow you maximum flexibility down the road as you add new elements at the front of your pipeline, which you inevitably will. Everybody's going to actually want to add more variables. By using JSON, you can easily expand that variable list without disrupting your pipeline later on. The other, I'll kind of speed up through these. The other great thing that we have is the ability to monitor. With AWS, we can monitor each of our elastic beanstalks in our Kinesis streams. They have nice monitoring features. Here's an example of, we have an auto-scaling feature that triggers when we have more than 20 megabytes of data coming in. It'll trigger an auto-scale and actually grow our cluster so we can handle the load. But you can have really great monitoring via these tools on AWS to keep an eye on spikes and stuff. So the summary of phase one, use JSON. We use the HTTP call requests to get the minimal amount of code introduced on the page. And we liked Elastic Beanstalk and Kinesis because it's auto-scalable. So as we began to ramp up our sites and got them all on board, they would auto-scale up to handle the load. And S3 was a great place to stick all the data for starters because it's reliable. And of course, all of the other processes later on rely on S3. So now that we have ingest out of the way, and you have to be able to have a very nice, confident ingest in your pipeline, you can focus on ETL, which is the next phase of the pipeline. The data that we got coming in from our websites is not clean. And I'm sure if you have a data pipeline, whatever's put on the page is scraped and sent back, and that can have a lot of mistakes on it. So ETL is going to have to happen. And our first phase of ETL, we decided to use EMR, and we did Hadoop. We decided to use EMR. And the reasons for this is because we knew pig. And so, I think sometimes that's how things evolve, is that you use what your team can do. And so we knew pig, and so we could code in pig Latin, so we created a Hadoop cluster that would grab the data that we were putting into the stream from S3, clean it up, and put it back into another S3 bucket, and it would be the cleaned and slightly aggregated data. Now, if any of you program with pig, you have to have a lot of UDFs to work with it because it doesn't have a lot of cool functions out of the box. We ended up having to make 50 UDFs in Python because, again, that's our coding language of choice. We could have done it in Java, but we like Python. And that is very important. And here's a snippet of our pig script. Some tips on if you do any coding in pig. I definitely recommend gzipping or getting your files gzipped. So you use these first two lines here to get compression. The next section down here is an example of how to call the UDFs. And a lot of times regexes scare people in other languages, but the regexes in pig aren't so bad. Version 2 of our ETL. So along came Spark, and one of the neat things about Spark is it allowed us to stream the data directly from Kinesis and remove the writing to S3, and we could actually process it in real time and in memory. The drawback with Spark, or streaming Spark, is Scala. That's a language that not a lot of people know. So I'm here to try, I'm a convert, because I'm actually convinced that Scala is not so bad. And if you know Python, I think Scala will not be that bad. And the way we got around it is a very important little trick, is we actually embedded SQL. We took our existing pig scripts, converted them to SQL, and embedded inside of Scala SQL. So we created a little SQL function. Right here is an example, and it is called by the Scala script. And so basically we used Scala as a wrapper and just basically did our ETL in SQL. And this will become relevant later on, and I think it's a theme that I've got around SQL. Another thing is, don't be intimidated by, this slide is here to show you a Python UDF and a Scala UDF. Basically the argument is they're not that different. Here's some commands that are in Scala and some commands in Python. So I'm trying to, I guess, speedily convince you that if you know a little bit of, if you know Python, I think Scala is doable. Once the ETL is done, you've got the data cleaned up and munged down a little bit. We got to come up with those funky variables that are predictive and model-based. And that's what I call the data science section, phase 3 of the pipeline. And the way we started our data science is through an investigative process where we used SAS on an EC2 node, a single EC2 node, and sucked the data from S3 using SAS and ran our stuff in SAS. Why SAS? It's because our data science folks are good at SAS. Everybody's, if you're in data science, most people know SAS. And it's great for guerrilla warfare and figuring out your models. The problem was, a single node of SAS, sucking the data from S3, processing it and pushing it back, takes 3 to 5 minutes, which breaks our 2-minute time through. SAS code example, again, I'm going to speed through this really quickly. Another SAS code example, we embedded SQL. We used another tip I've got for you. If you're going to do stuff in SAS, I know there's a proc SQL camp versus a not proc SQL camp. I definitely recommend trying to do stuff in proc SQL because, again, SQL is my theme through the pipeline. All these newfangled products that are coming out, and if you try to interchange them, the one nice commonality across all of them is that you can usually take your code in SQL and re-embed it inside that new product. So it was very easy, if you did it in proc SQL, to get us to the next step, which I call the production version of our model. So now once we've figured out the models, using SAS here on the bottom, what we can actually do is store those models, those coefficients, or those model parameters in S3. And then, since I wrote most of the team wrote most of the stuff in using proc SQL, here comes Redshift. Redshift can suck data from S3, PostgreSQL, take the proc SQL, put it in Postgres, grab the models, and we converted everything in our data science phase to use Redshift. And suddenly, our processing time, our data science processing time, is 100 seconds. Pretty impressive. I think, again, I can't say enough good things about how if you got something that you think is really fast and you don't think that it can be beat, I always recommend trying it in Redshift and see how fast you can get it going in Redshift, because it's always shocked me how fast Redshift is. It's beaten some of our processes in PySpark, some of our processes in Scala. Redshift is just really great at sucking data in and processing it as long as you can get it all into SQL. And now with the UDF functions, it's opened up a whole new set of things. I'll skip my Redshift code example because I don't have any time. Finally, once the pipeline has the data science part done, it's got these nice little neat files. We now need to expose it through an API endpoint. So the last step is to push it into an Elasticsearch cluster for indexing, and Elasticsearch is great for exposing stuff through an API endpoint, and it's great for searching data, right? The way we did it at first is, since we had an EMR cluster up and running, we actually wrote a little pig script to push the data from S3 into EMR. And that's because, people might not know this, the Elasticsearch has a really great jar or pig has a great jar that will read data directly into Elasticsearch and preserve the formatting of the variables. So your date times don't change. I don't know if you had any challenges reading data into Elasticsearch, but it can be challenging, especially with formatting. So this is an example of the jar that is available, I think, via Amazon. And it's really simple just to define your Elasticsearch cluster and then read the data into HDFS and then push it into Elasticsearch. All of the formatting is preserved. So our final step, that was slow because obviously spinning up an EMR cluster and reading the data in HDFS and then removing it back is slow. So we just decided, why don't we push it directly from Redshift? Redshift was actually being run in an EC2, being called via an EC2 node. We just pushed the data from the EC2 node into Elasticsearch directly. And this is a script example that we used, and there's a couple of tips on there on converting your JSON to the right format, which is something that was a pain for us to figure out. But this is our final data pipeline in all of its time, latency, and throughput. So basically, we're ingesting about 100 gigabytes a day of data throughout the pipeline. It's being processed in milliseconds with the Spark. And then we're doing our ETL in 30 seconds. And our data science is being run on Redshift in 100 seconds and being pushed out to Elastic through an API. And the whole throughput is about 140 seconds from click to a table, to an endpoint. This is a more visual representation of what's happening in our process. So basically, the bulldozer is shoving the giant rock, and then Kinesis, or Spark, is smashing it into little pieces. The data science bulldozer's scooping it up and processing it and creating a diamond at the end. That's probably. So to summarize, the lessons learned. These are the couple of no-does, but it took us a while to figure this out. With our V1. We had a lot of storage steps with S3. We kept writing the data. If you can remove the storage points, speed up processing obviously within one of the stages, and then finally combining the stages, which is hopefully down the road, will ultimately speed us up to even faster. I think, should we open it up? We'll be outside for after the presentation for more questions, but if you want to stay, we'll open it up for some questions if you have any.
Yeah, can you hear me? Oh, okay. So we won't have time to talk about your data science, so.
That's too bad.
Yeah, so come meet us, Rick and Hearst booth, but.
Yeah, we'll be at the booth 1156, Hall C. And we can talk about all this stuff, and you can play with the demo tool that I didn't really get to show you very much of.
Yeah, I think just let's summarize, like from conclusion, when we worked on the Clickstream, so I think we provided, with Hearst, with the technology to do that type of journey. This is the reason why we call it the life of a click. It's really the journey of organization, enterprise organization, when they start processing vast amount of data. And you don't need an army of resources to do it, because most of the services are fully managed. So using that really creates you the pipeline. And I don't know if today we announced a quick insight. So now you'll have an end-to-end, I think, data flow and visualization as well. So that's your booth, 1156. So if you want more information, and Hearst is hiring as well. So sorry that the demo didn't work out. We will fix, and I like the fact that you have the quick tips, so you can later on print or download this presentation and really use that for your day-to-day work. So thank you very much, guys.
Thank you.
Pleasure. Thank you.